In 2003, an astronomer named Mike Brown found something at the edge of the solar system that broke his brain a little, not because it was enormous, not because it was glowing or moving strangely or sending out radio signals. It broke his brain because of where it was. Because according to everything science understood about how the solar system works, about gravity, about orbits, about the physics of how objects move around the sun, this thing could not be where it was. Full stop. It should not exist in that location. They called it Sedna. And Sedna, honestly, looked boring on the surface. It was a reddish, vaguely round, icy object, the kind of thing astronomers find all the time out past Neptune. Nothing weird about that. What was weird was its orbit. Its closest approach to the sun, the point where it swings in as close as it gets, was 76 astronomical units away, 76 times the distance from the Earth to the sun. And at its farthest point, it drifts out to nearly 1,000 astronomical units. That's so far that the sun, from Sedna's perspective, would look like a slightly brighter star. Nothing more. Here's why that matters. Objects in the outer solar system get their orbits shaped by gravity, mostly Neptune's gravity, which acts like a cosmic sculptor, nudging things into predictable paths. But Sedna is so far from Neptune that Neptune's gravity essentially doesn't reach it. So who shaped Sedna's orbit? What force pulled it into that extreme, stretched-out path? Brown looked at the data, looked at his models, looked at what he knew about the solar system, and had no answer. Nothing in the known solar system could have done this to Sedna. He filed the observation, made a note, and moved on. Because one weird object can be a fluke, science doesn't upend itself over one data point. That was the first clue, and at the time, nobody really understood what it was pointing at. 9 years passed. Then in 2012, Scott Shepard, an astronomer at the Carnegie Institution for Science, found another one. Another object with a Sedna-like orbit. Impossibly far from the sun at its closest approach, orbit shaped by a force that wasn't there. They called it 2012 VP-113, which is not exactly a memorable name, but the discovery itself was very memorable. Because now there were two objects. Same bizarre orbital signature, both of them sitting in a region where, by all known physics, no object should have an orbit like that. Shepard and his colleague Chad Trujillo started looking more carefully, and then they noticed something that made the whole thing a lot weirder. It wasn't just sednoids. There was a whole group of smaller, less extreme objects, trans-Neptunian objects, objects orbiting the sun beyond Neptune, and their orbits were clustering, pointing in the same direction, not randomly scattered the way they should be if the solar system were just doing its thing. Arranged. Almost like someone had taken a handful of these distant icy rocks and lined them up deliberately. Trujillo and Shepard published a paper in Nature in 2014 laying out what they were seeing. They stopped short of saying a planet did it, but they asked the question out loud, what gravitational force could possibly explain this? That paper landed on the desk of two astronomers at Caltech, Konstantin Batygin and Mike Brown. Yes, the same Mike Brown who found Sedna a decade earlier. And they did something that takes a certain kind of scientific courage. They took the clustering seriously. They ran the numbers. They ran them again. They built computer simulations of the outer solar system, trying every possible explanation. The Milky Way's tidal pull, passing stars, the gravity of all 8 known planets combined. Nothing worked. Nothing reproduced what they were seeing in the data, so they tried something else. They added a planet, not just any planet, a specific one. 5 to 10 times the mass of Earth, orbiting somewhere between 500 and 800 astronomical units from the Sun, on a highly elongated, inclined orbit, taking between 10,000 and 20,000 years to complete a single loop around the Sun. They ran the simulations with that planet in the model, and suddenly everything lined up. Every clustered object fell into place. Every misaligned orbit corrected itself. In January of 2016, Batygin and Brown published their findings in the Astronomical Journal, and they said it clearly, there is probably a 9th planet in our solar system, and nobody has found it yet. Now, you'd think the scientific community would have gone absolutely wild for this, and some of them did, but a lot of them were skeptical, which is fair. You don't rewrite the solar system based on a few clustered orbits. That's not how science is supposed to work. So Batygin and Brown kept digging. What's worth understanding about these two is that they weren't chasing a headline. Brown, specifically, is the guy who killed Pluto. He's the one whose discoveries in the early 2000s led to Pluto being reclassified as a dwarf planet, which is why his Twitter handle, for a while at least, was literally Pluto Killer. He doesn't have a reputation for wild claims. And Batygin, who's the theoretical side of the partnership, had already established himself as someone who does the math carefully before speaking. So when they said 5 independent lines of evidence, they meant it. First line, the clustering. 6 extreme trans-Neptunian objects, all with their perihelia, their closest approach to the Sun, pointing in the same direction. The probability of that happening by chance, according to their calculations, is 0.0007%, not low, essentially impossible. Second line, tilted objects. Certain trans-Neptunian objects orbit the Sun at nearly 90 degrees to the plane of the solar system, as if something enormous reached in and knocked them sideways. Planet Nine's predicted gravity, running through simulations, does exactly that. Third line, objects orbiting backwards. Some distant objects actually orbit the Sun in the opposite direction to everything else. Counterintuitive, bizarre. Planet Nine's predicted gravity, in simulations, produces exactly this effect as a side product of its gravitational influence on the outer solar system. Fourth line, Sedna itself. Sedna's impossible orbit was the original mystery. Planet Nine explains it. And then the fifth line, which came later, 2024, a new paper from Brown and Batygin and 2 colleagues. They looked at 17 objects whose orbits cross inside Neptune's path. These objects should not exist. If something's orbit brings it that close to Neptune, Neptune's gravity should have flung it out of the solar system long ago. They modeled every known force acting on these objects, and the only thing that keeps them in stable orbits, the only thing that acts as a counterbalance to Neptune's ejecting force, is the gravitational pull of a massive object sitting far out in the same general direction. 5 lines, all pointing the same way. Batygin, in a podcast interview in 2026, put it plainly. He said, "There are currently no other explanations for the effects that we see. He's not someone who speaks in absolutes." That sentence, from him, carries weight. But here's where it gets complicated. Because not everyone agrees. And the disagreement isn't stupid, it's legitimate scientific pushback, and it matters. Samantha Lawler, an astronomer at the University of Regina in Canada, has been one of the more consistent skeptical voices. She worked on something called the Outer Solar System Origins Survey, which found more extreme trans-Neptunian objects than had been catalogued before. And when her team added those new objects to the dataset, the clustering that Batygin and Brown were pointing at, it got weaker. Not gone, but weaker. Lawler's argument is about observational bias. These distant icy objects are incredibly faint. Scientists can only see them when they're in certain parts of the sky, close enough to their perihelion to reflect enough light, which means the sample isn't random, which means clustering in the sample might just be an artifact of where telescopes were pointed, not a real gravitational signal from a hidden planet. She said directly that she's convinced there are strong observational biases in the ETNOs that we need to be very careful about. That's not a fringe position, that's a reasonable scientific concern. And then there's a completely different challenge from a completely different direction. Harsh Mathur at Case Western Reserve University and his colleague Catherine Brown, not the same Brown, published a paper in 2023 looking at something called MUND, Modified Newtonian Dynamics. It's a theory originally developed to explain why galaxies rotate faster than Newton's laws predict, an alternative to dark matter essentially. And Mathur's team found that when you apply MOND to the outer solar system, it might explain the orbital clustering without needing any hidden planet at all. The gravitational pull of the dense core of the Milky Way, behaving slightly differently than Newton predicted at extreme distances, could be doing what everyone assumed Planet Nine was doing. Mathur himself said, "We took the theory, and boom, it explained all of these things," which is a remarkable statement. And also an uncomfortable one for Planet Nine believers. So now, there are 3 camps. Planet Nine exists. Planet Nine doesn't exist, it's observational bias. And Planet Nine doesn't exist, it's modified gravity. None of them can prove their case. All of them have real evidence. And the solar system, which has been sitting out there for 4.5 billion years not caring about any of this, keeps its secrets. And then, just as the debate was settling into something like a stalemate, something new showed up. July 2025. Japan's Subaru Telescope, perched on Mauna Kea in Hawaii, had been running a survey called Fossil, Formation of the Outer Solar System, An Icy Legacy, a project specifically designed to find ancient remnants from the solar system's earliest days. And they found one. They nicknamed it Ammonite. Officially, it's 2023 KQ-14. It's a small icy body, somewhere between 220 and 380 kilometers across, with an orbital period of 3,998 years, meaning it takes almost 4,000 years to go around the Sun once. The team, led by Fumi Yoshida of the University of Occupational and Environmental Health in Fukuoka, confirmed it's only the fourth sednoid ever discovered in human history. Fourth, in all the time humans have been studying the sky. Fourth. So finding another one was significant on its own. But what made Ammonite genuinely strange was its orbit. The three previously known sednoids, Sedna, 2012 VP113, and a third one called Liliakuhonua, all have orbits that cluster in the same general direction. That clustering was part of what pointed scientists toward Planet 9 in the first place. If Planet 9 is hurting these objects gravitationally, they should cluster. And the first three did. Ammonite doesn't. Ammonite's orbit points in a completely different direction. It doesn't fit the pattern that Planet 9 supposedly creates. Yukun Huang of the National Astronomical Observatory of Japan ran the orbital simulations. And what he found was unsettling enough that he said it out loud in a press release. The fact that 2023 KQ-14's current orbit does not align with those of the other three sednoids lowers the likelihood of the Planet 9 hypothesis. That's a scientist saying quietly but clearly that the best piece of new evidence they had just cut against the theory. And then he said something even stranger. He raised another possibility. Maybe Planet 9 did exist, once. Maybe it shaped those early orbits billions of years ago, back when the solar system was still forming and chaotic and everything was being flung around by close gravitational encounters. And then, maybe it got ejected. Thrown out of the solar system entirely by a gravitational interaction with Jupiter or another giant planet. In which case, what science is seeing now isn't the fingerprint of something that's currently out there. It's the ghost of something that's gone. The memory of a planet. Think about that for a second. The orbital clustering, the impossible sednoid paths, the 17 objects that should have been ejected but weren't. All of it could be the echo of a world that no longer exists. A gravitational fossil. The solar system still carrying the scars of something that left 4 billion years ago. Which brings everything to right now, 2026. Because sitting on a mountaintop in Chile's Atacama Desert, the Vera C. Rubin Observatory has come online, and it is genuinely the most powerful tool ever built for finding something like Planet 9. The numbers around this telescope are hard to process. It carries a 3.2 gigapixel camera, the largest digital imaging device ever constructed for astronomy. Every 40 seconds, it captures a new region of the sky and sends 20 terabytes of raw data to a processing facility. It will scan the entire southern hemisphere sky every 4 days. Over 10 years, it expects to catalog around 10 billion objects. 10 billion. Planet 9, if it exists, is faint. It would appear as a small, slow-moving dot, distinguishable from background stars only because it shifts position slightly over weeks of observation. Exactly the kind of thing Rubin was built to find. Scott Shepard, who found the second sednoid back in 2012 and has been chasing this mystery ever since, told NPR that Rubin has around a 70 to 80% chance of finding Planet 9 if it's real. That's not a guarantee. But for a hunt that's been going on for a decade with zero direct detections, 70 to 80% is almost electric. And Batigan, who spent years defending this theory against skeptics, whose name is now permanently attached to it, went on a podcast in 2026 and said something that makes the whole thing feel urgent in a way it hasn't before. He said, "There's a new telescope that came online called the Vera Rubin Observatory, and as it collects data this year, we will, I think, know one way or another whether Planet 9 is really out there or not. One way or another. This year." The teams at Rubin aren't just passively scanning. Batigan and Brown's simulations have narrowed down where Planet 9 should be. They've been able to identify which regions of the southern sky it's most likely hiding in. Rubin's survey is covering those regions with priority. The search isn't random, it's targeted. They've already ruled out 78% of the predicted search space using older telescopes, Pan-STARRS, the Dark Energy Survey, the Zwicky Transient Facility. Rubin is going after what's left. If Planet 9 is in that remaining 22%, it's going to show up in the data. If it doesn't, that's also an answer. And that answer might be the more unsettling one, because if Rubin scans everything and finds nothing, if the search comes up empty, then science has a problem that's much bigger than a missing planet. Either the clustering is fake, caused by observational bias, the way Lawler has been saying for years, which means the pattern that launched this whole investigation never existed, which means science got fooled by the limits of its own instruments, or the clustering is real and something other than a planet is causing it, which means gravity behaves differently at the edge of the solar system than Newton and Einstein said it does, which means MUND, or something like it, is correct, which would be one of the largest revisions to physics in a century. Or Planet 9 is real but farther out than predicted, lurking beyond even Rubin's reach, out past 800 or 1,000 astronomical units, too faint to see with anything humans have currently built, in which case the mystery just gets longer, not solved. There's also Ammonite's option. The ejected ghost. Maybe it was there, maybe it shaped everything, maybe it's gone now, somewhere out in interstellar space, millions of years past Neptune and the Kuiper Belt and the Oort cloud, orbiting nothing, unreachable, undetectable. A planet that was ours once and isn't anymore. Any of those answers is a big deal. None of them are comfortable. And here's the thing that keeps pulling at this story, the part that doesn't go away. In 2003, Mike Brown looked at Sedna and thought, that's odd, one object in the wrong place. He filed it and moved on. 23 years later, Sedna still doesn't have a clean explanation. The explanation that came closest, Planet 9, is now being questioned by the very object Ammonite was supposed to help confirm. Batygin himself has said that if something slightly different from his prediction turns up, he'd be the first to say, that's not Planet 9, that's Planet 8.5. He's not married to the specific model. He's married to the idea that something is out there. And maybe that's the most honest version of where science is right now. Something happened in the outer solar system. Something shaped those orbits. Something put Sedna where it is. That something has been unnamed and unseen for over 2 decades. It might be a planet. It might be modified gravity. It might be the memory of a planet that got thrown out long before humans existed. The solar system is 4.5 billion years old. Humans have been looking at it carefully for maybe a few hundred years. Carefully is maybe too generous. Seriously, with real instruments, maybe 70 or 80 years. The idea that it would have no more surprises after that is the kind of assumption that keeps getting embarrassed by data. Sedna was the first embarrassment. Ammonite might be the latest one, and somewhere in Chile, a camera the size of a small building is scanning the sky every 40 seconds, looking for a dot that moves slowly enough to be a world at the edge of everything known, a world that either exists and has been hiding for a decade, or doesn't exist and has made science question things it thought were settled. Either answer is going to matter. A lot. So what do you think is out there? Drop it below. Genuinely curious what people make of this one.